This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Now let's talk again about the random generator class and the dice class. I suppose everything is clear with the random generator class. Again, you don't have to know how it works, but you should know what it's doing. Basically generate some random numbers. Now we have another class which is called dice. Dice is not the dice. You can have six sides. Sometimes it might have 3 sides. Maybe you have seen a dice with 3 sides. Okay? It might have 8, 12, and so on. Usually, in this example also, we will be dealing with dice with 6 sides. So we have the class dice. As private members, it has the number of sides. Usually it's going to be 6, 1, 2, 3, 4, 5, 6. My roll count, we are going to count how many times did we roll how many times did we throw the dice. So if we throw it once, this my roll count is going to be incremented by 1. Those are the private data. The public data, the constructor, it must take an integer which basically tells us how many sides do we have for the dice. If we give 2 sides, what are we talking about? If the dice has 2 sides, it's what? Is it possible or not? Can we have a dice with 2 sides? It's a coin. Yeah, it's a die. Basically, it's a coin. Roll, basically this roll returns a random roll. It returns a random number from 1 to number of sides. Okay? So if it's 6, it's going to return a random number from 1 to 6. Basically, this roll function is using the random integer function that we previously saw. Number of sides returns how many sides do we have. Basically, it returns my side. Because we cannot access this private data directly, since they are private, that's why we use num sides. Number of rolls returns my roll count. How many times this dice has been rolled. You can check the implementations, but I don't want to bother you with that. For the time being, I'm just going to tell you the following stuff. I'm going to run the code. We're going to see the output. And then we are going to explain the code step by step. So, scene, ignore, scene, get. Let me run the code. We want to find basically the summations that we saw previously. So, a number of trials. Let's say I'm giving 50 trials. Now I say those numbers, so let me give a smaller number of trials, like 10 maybe. Now I say those numbers, sum 2, in order to find sum 2, on average I should roll the dice 23 times. If I want to find the sum 3, on average it says I should try 9 times. To find the sum 4, on average I should try 7.1 times, and so on. Okay? But this is with 10 trials. What do I mean with 10 trials? 1 trial, this is what I mean with 1 trial. Remember, 1 trial is following. I threw the dices up until I get number 2, sum 2 of both of them, okay? This is called 1 trial. 2 trials, again, I threw them up until I get number 2. This is for the first line, okay? Well, let's say for the first time I throw them 40 times and I got 2. For the second time, I throw them 15 times, and I got 2, and so on. So I sum up those number of rolls of throws, and I find the average. This is 10 trials. Okay, I divide them by 10. The same applies for 3, 4, 5, and so on. But this is with 10 trials. You see that you cannot relate between the numbers that we see there as output and those numbers here. However, let me increase the number of trials from 10 to, let's say, 100. Now you see numbers are getting, from 2 we have there 37, but we got the probability of 1 over 36. On average, we're expecting 36 rooms. For 3, you see we have there 19, but we have here 18. For 4, we have there 11.59. We have here 12. For 5, we have there how much? 6.47. We have here 9. And so on. What if I increase the number of trials to be this much? Now, if you thought that the computers are fast, they are not really. You see that the numbers are getting closer to the probabilities that we give as we increase the number of trials. Okay? So yeah, it's 36 on average. In order to get the sum 3, it's 18. In order to get the sum 4, it's approximately 12, and so on. As we keep increasing this number, it's 100,000. I can give 1 million, 1 billion, but we don't have time to do that now. If you don't trust me, let me give a very big number, let's say 1 million, 1 with 3 zeros. Just see how much should we wait in order to get only for number 2. The computer is slow, by the way, if you thought it's fast. It's doing some calculations. Did you get this result previously or not? You might think, oh, it's not working, but it's working. So you see, in order to get number 2, in 1 million trials, the average is 36 times, approximately. In order to get number 3, the average is very close to 18. In order to get number 4, it's very close to 12. In order to get number 5, it's very close to 9. 7. In order to get 6 is to 7, and so on. You see, the expectations are very much close to what we saw. And do you know why we calculate more when the number is getting bigger for the number of trials here, expectations? Because we throw it more times, that's why. Okay. So in order to get 12, we should get approximately 36 here. That's why we are throwing, we throw it multiple times in order to get it more. I mean, we throw it here 18 times and we throw it here 36 times. That's why on average this is twice greater than this one. So we wait more, okay? I'm going to help you with probability also, so remember this stuff. And this is called the Chebyshev theorem. So when we saw it with 10 numbers, you know, the relation, we cannot relate between those probabilities and probabilities we got. But as we increase the number of trials, the probabilities are getting exactly to what our theory says, our intuition says. And this is the Chebyshev's theorem. Okay? You can see on it as kind of a proof, in quotation mark, of Chebyshev's theorem. Did you understand what do I mean with one trial or not? Okay. Since I remember from past years that students had problems understanding what do I mean with one trial. Well, one trial is the following. So let's say I want to fight only for number 2. On average, how many trials should I do? And I'm trying 1,000, let's say 1,000 trials. So this is the table. This is just for the number 2. So trial 1, not the rows. Okay, this is for getting 2. Let's say trial 1, trial 2, trial 3, up until trial 1000. Our aim is to get sum 2, and we roll the dice up until we get sum 2, and this is called one trial. So, trial 1. I'm doing another table, trial 1. I threw it once. Okay. Number of roll. and this is the sum I get. Should get 2. And this is the first trial. I throw both of the dices. This is the first row, and let's say I get 5, but I should get 2. So this is not a success. I throw it again, and I get 9. This is again not a success. I throw it again, I get, let's say, 11. Not a success. Throw it again for the fourth time. I rolled both of them, and I get 3. Not a success, and so on. Let's say I come to the 41st throw, and I get 2. Well, this is a success. So first trial has 41 rolls. Okay, this is for trial 1. I repeat it again for trial 2. Let's say this is the first trial. For trial 2, I'm trying to get 2. So I roll both of dices. This is the first roll. And I get, let's say, let me erase those guys. Let's say I get 9. I don't like it. It's not 2. I throw it again. I get 9 again. It's not what I expect. I throw it again, and I get 3 for the third time. It's not what I want. I throw it again, and I get, let's say, 5. It's not what I want. And let's say during the 25th roll, I get 2. Okay, this is where I finished. So the second trial has 25 rolls. Okay. I repeat this 1,000 times. So that's I have here 30. Maybe I won't have here 1 only. I'm lucky in that trial. And let's say here I have like 26. What I do, I sum up those numbers and divide them by number of trials. Okay? So let's say I sum up from 1 to trial. This is n. Well, let's say I is equal from 1 to trial. And then I divide this by the number of trials. And here I put 2, and let's say the average was 37.83. Okay, so this is how I get those numbers. I repeat the same thing for 3, again, trials, but I want to get 3, not 2. And one trial, I mean, up until I get 3, I count the rows, up until I get 3, find the summation of them, find the average, and let's say I get here like 17.92, and so on. Okay? So we saw how it's done. We saw the logics behind it. We saw the output node. Let's see, and let's go through the codes. Okay. The most important part here is the roll test. The roll test is basically what I just explained to you on the board. The target is the sum that we are targeting in. In our case, it was 2, okay? And experiments is the number of trials that we saw on board. So, let's first explain the roll test function, and we will go on with the others. Precondition means that, I mean, what are we expecting as an input here? Because I cannot target 13 or 15 or -1. So the target is greater or equal to 2 or smaller or equal to 12. And the number of trials should be greater than 0. I mean, I can try only once, but I can try multiple times, as I showed here. I can try 1,000 times up until I get 1. Okay? And one trial, again, one trial means a number of throws up until I get some desired. Okay? This is one trial. One trial might mean I might throw the dice 40 times, since I didn't get for 40 times the sum I wanted to. Now, we have included the Dice.h, the library that we just saw. We are declaring 2 variables, dice, d1 and d2. They have both of them 6 sides. Total is the total number of rolls I have did. Basically, this summation here is the total that we saw on board. Our start from 0 up until trials, and this is what I do. So this is only for one trial. I roll it, D1 roll, meaning I get a random number between 1 and 6, plus random number between 1 and 6 for the second one, up until I don't get the target. So this is one trial. I throw them up until I don't get the number I want to find. If I don't get it, I increase the number of rolls and repeat this. Okay? When I get it, I go outside, and the number of rolls for the trial that is just finished, I increment it, I put it to the total. So basically total is this summation here. You can maybe record this stuff here. So the total we are talking about is this summation here. And one trial might have one trial. This is for one trial. 1, 2, 3, 25. So the first trial might have 41 rows. Okay. Up until we get the sum 2, we roll the dice, and this number of rows are put in the overall on the grand total. Okay, as it's shown here. So this is one trial. I'm incrementing the number of rows, and when I have the target, I just put this number of rows to the grand total. With this for loop, I repeat the trials, let's say 1,000 times, and afterwards I return the average of trials. I convert this total to double. This is how it's converted, since when I'm going to divide it, it's going to be probably a double number. That's why it's better to convert this integer, total integer, into double. And I return it, and so this is how I figure out the average number of rows in order to get a certain target. So this is only for 2. Okay? If we go in main, what we do is the following. We want to find the average number of trials for 2 up until 12. We start with 2, and we go up until 12. So we call the roll test function, and this is it. Okay? We print k. K is initially 2. We have tab. This is more empty spaces. And we call the roll test function with parameter k, meaning the sum I want to be k, and number of times, how many trials I want to have, 1,000, 2,000, or whatever. And I call the roll test function. So this is it. Again, in main, number of times, this is the number of trials, number of times for one trial, total rolls accumulate for all trials. This is k, starting from 2 to 12, the summation is that much. Please enter number of trials. I enter the number of trials here. Total rolls initially is 0, and this is what I do. Basically, we don't need total rolls here. We need it here. But okay, no problem. This is it. I'm going to run the function again, the program again. So I want to try it with 1,000 trials for each sum from 2 to 12. And this is what I get. Okay? If I increment it to 1,000, I'm getting, if I increment to 10,000, let's say, I'm getting more and more precise values because of the Chebyshev theorem, which emphasizes exactly what we are doing. As we increase the number of trials, the probability that we are going to get will be very much closer exactly with the calculations that we did intuitively, okay? With the theory, with the expected part we did in theory, okay? Basically, Chebyshev says if the number of trials is infinite, then exactly we will have for number 2, 36 trials, okay? 36. You would expect on average 36 times through 2 dices to get sum 2, okay? If the number of trials gets infinite. But of course we cannot do it infinite in practice, but large numbers are sufficient for our needs. What is this one? Can you tell me, how do you call this stuff here?
Roll test.
Yeah, but roll test was defined after main. Why did we put it here? Okay, this was the prototype function. It means that it tells to the compiler don't throw in, because we cannot use roll test. We cannot use roll test if we don't know what roll test is. Okay, and in order to use roll test, compiler doesn't start from the end. It starts from the beginning, from left to right. Okay, it would have been a mistake. But with that particular line, we're telling, okay, it's not a mistake because roll test is defined after main.
That supposed to be in the header though?
Not in the header. It was supposed to put roll test here. Copy paste it and put it there.
The code head.
The
Would that supposed to be in the header?
Not really. Yeah. If you are talking about classes, then yes. We have here prototype functions also, like this one, this one, this one. We are just declaring them, okay? And we are defining, so this is Dice.h, Dice.cpp. This is the implementation of the functions. They're kind of prototype functions, yeah. So dice, roll, this is how it's working. This is straightforward, really. The dice function. Any questions about, do you want me to go through at least the dice header? I think it would be good for you, beneficial for you if I explain all of those functions. Okay, so you remember this stuff here? I declare a dice D16, okay? So basically what is this doing? It's calling, this is called a constructor. Always when I declare a new dice, variable of type dice, it's calling this function here. It takes a parameter integer and it gives the number of sides. It gives the number of sides. It's implemented here. So when I declare a new dice, my roll count is initially 0 because I haven't rolled the dice yet. And my size is the size that I give. You know, remember my size was a private member. Maybe I think I'll take like 5 minutes to explain this stuff and then go through the homework and some midterm samples. This is the way that we will be explaining the classes. Which one? Okay. This one. So, this is the class dice. Here we have some private data. Private data are those. My roll count. And my sides. The number of sides for the particular dice. Both are integer. Public data are the constructor, and the constructor has always the same name as the name of the class, okay? And this is the first function that is called when we declare a new variable of type dice, of the class dice. So we have dice, we have roll, and we have what? Num_sides and num_rolls. Two functions. Number of sides and number of rolls. That means that each dice has those member functions and member properties. Every dice. Now, let's see how this dice is dealt with. This is the constructor, dice. My roll count is initialized to zeros, and my size is equal to sides. This is it. The roll dice, when we throw it, we generate, you remember random generator class? Okay. So we declare a new variable of this guy, random generator. My roll count, when we roll it, my roll count is incremented by 1. And what are we returning? Basically, if we are dealing with dice with 6 sides, from 1 to 6, we want to return a random integer. And you remember that the random generator class had a function which was called random integer, and it returns a random value from low to max. Low in our case is 1. Max is my size. My size is this private data. So from 1 to 6, in our case, if my size is 6, we're returning a random number. This is how roll works. So we saw dice, we saw roll. Number of sides is straightforward. Since we cannot directly access my sides, we can call this function in order to return my sides. We have here constant, meaning that we cannot change my sides. Okay, it should remain constant. We cannot change it in this function. Number of rows is also private data. So in order to get my roll count, we are using this function number of rows, and it returns my roll count. Okay? So we saw all of the functions. What are they doing? Again, private means that outside from the class, no one can access those data, but all member functions or member data can see them. So those functions are public, but they can see the private data. But other functions outside the class cannot see the private members of the class. Maybe I should have done it initially, but okay. So this is the class side. We have those private data. We saw it. The most important part are those 4 functions, which we already explained. So in order to use them, again, remember the class. The name of the class is RandGen, random generator. In order to use them, you can see example here. Okay, so you declare a random generator. And then in order to use one of those functions, let's say random int, 1 my side, which is this one. Random it from low to max, from 1 to my sides. Okay, it's called here. Okay. Listen. Any question about this stuff? We are going to do it with generating random numbers for your next homework. I don't know exactly what it's going to be. I suppose it will be with robots and some stuff that are moving randomly, and you're trying to get away from those robots, but you'll see it, I suppose. Questions? No. Did you finish doing your homework, your assignment? No? What? It doesn't check for the others. Okay, that's why you should go up until the end. First, let me start with the homework. I don't have to delete it, I suppose. This stuff here should be enough for me. Okay, how would I have done it? Is this way. So let me find the homework. Did I find the homework? Okay, homework 4. Okay, this is it. Let's go with this example. So again, just let me refresh your memory. We have a pool of words that you give us an input. Then you give your word. And what you're trying to do is the following. Try to correct kind of spell checking stuff. You know, if it's misspelled or not. And if it's misspelled, if it's a mistake, you assume that the words in your word pool are correct. And you try to find mistakes, if they are misspelled, or so on. So you try to find matches here which are close to the word that you have given and display them. Okay, how are you going to do that? First, I'm giving you the algorithm, not the code. Even not the algorithm, the way how to do it. I would have done it. You might maybe come out with better algorithms. You never know. So let's take the example of your friend. So let's say this is our pool here. Venice, and blah blah. Okay? And I'm entering a word which is menace. What you should do is the following. You should take this word and check it one by one for all of the words in this pool. And if one, they have the same length, so length should be the same. The length of the word that you gave as an input and the one from the word pool should be the same. Two, mistakes should be less, like this, less or equal to the length of the word. What I would have done, this is what I would have done, or take a child, and this is maybe the best way to write your programs and say, okay, how are you going to do this stuff? You say, okay, I'll take menace and start one by one. Menace and Dennis, do they have the same length? Yes. So we should, the output in our case. So this is the pool. This is the word. I take menace and compare it with Dennis. First I should check, do they have the same length? Yeah, they have. And the length is 1, 2, 3, 4, 5. 5 for this one. Is the mistakes, the number of differences, mismatches, smaller or equal to the length? Yes, it is, because we have Dennis here, we have Dennis here. They differ only on the first character. So I should output Dennis. I'm done with this word. I go to the other one. Menace, Venice and Menace. Are they the length the same? Yeah, it is the same. The number of mismatches is 1, M and V. The others are the same. So I'm outputting Venice also. Menace and blah, blah, blah. Are they the same? No. This is 6. This is not 6. Okay. But even I give something with 5 words like A, B, C, D, E. This is 5, but the mismatch is greater than 5. So, this is what you should do. In order to do it, what's the hard word? The hard word is, the hard part here, is to take one word from this stuff. Okay, start from the beginning, take a word, compare it. Again, take another word, compare it. Another, take a word, and compare it up until the end. How are you going to take a word from the pool? Exactly. Words are separated with spaces, okay? Except for the first word, maybe. You might do some exception, okay? But there is empty space here. So, let's say for the first index, you should find, for the first word, you should find only the first space here. And you take Dennis, okay? And you take the substring from index, let's say 0 up to this one. This is all the string. This is the @ sign, okay? And you compare it, okay? So first function is take a word, maybe. Maybe you can write the function take a word. Okay, but how are you going to take the second word? Ideas? Yeah, talk. I see. Yeah, very nice. So what you're saying, if you took this word, then you start from here, you delete this part, and continue. Maybe you can do it like that. Well, there's a problem. I'm not sure, but because I didn't write the concept of the homework. What if there are multiple empty spaces between the words? Did you think about that? Although I didn't read it at the document, I didn't write the homework. This was not my concept. But what you shouldn't give assumptions like you say saying the assumption is that there's exactly one empty space between the words. You should not give this assumption. You don't have this assumption. So there might be multiple empty spaces. Even in the beginning, you might start with empty spaces. So how are we going to do that? You might have like, okay, one empty space here, one here, two empty spaces. Maybe your program is still going to work, okay, even if you take because you take up until you go to the empty space, basically your string, your word is going to be an empty string. If you compare empty string with manys, it's not the same length. Okay, it's going to work. But if you want to be sure, then you're like this. You know, let's say this is the index 5, and you're trying to take the next empty space. If this is index 6, okay, then just remove this part and start from here, up until you get something here. Okay, this is the stuff. But even if you write a while loop here and use something like, let's say, pool find empty space. Okay, you return the index, and then you use pool substring from index blah blah up until the end length. Okay, meaning that you started with Dennis, okay, but now the pool is not Dennis, it's this one here. Okay, then this one here. But pay attention, the initial pool should be, you shouldn't use the pool, so you should write, if this is the pool, you should write another temporary pool, and you can just take one word, compare it, then start from here. If this is okay, start from here, and so on up until the end with the while loop. Then, so take a word, we saw it, you are going to use this, find and substring. The second part, find number of mismatches. Let's say that I have a word. This is another function. It might be another function. I have word 1, which is taken from the pool, let's say Dennis, and word 2, which is given as an input, let's say Menis. And I want to compare in how many characters do they differ. How am I going to do that? Of course, initially I should check the length, okay? So let's check the length. If the length is not the same, then just take the other word from the pool. If the length is the same, then call this function, find number of mismatches. How am I going to do that? Because you know the number of mismatches should be greater, should be less or equal to the length. I'm going just to write very briefly a function which is going to return the number of mismatches. Okay, mismatch. You can assume that those are strings. Word 1, this is taken from the pool, and word 2. Of course, you can also assume that they have the same length. So what are you going to do? Are you interested here? Are you looking here? I mean, if you're not interested, we can just go. So we are trying to find the number of mismatch between the pool and this guy here. Word 1 and word 2. We check character by character. Initially, counter is 0, meaning we don't have mismatches. So we start from the 0th index. We go, since the length is the same, let's say word 1 point length, semicolon, you increment I++. If, how are we going to do it? So we start, let's say we are comparing Dennis and Menis. We are starting character by character, corresponding characters, okay? If those two are not the same, we increment the counter. Then we go to the next one. If they are not the same, increment, otherwise don't do anything. So if word 1 at I is not equal to word 2 at I, Then very nice. Counter plus plus. And you do it from 0 up until the length. What should we return? The counter. I mean, this is an easy piece of code, but very important. If this counter is small or equal to the length of the word, then print it as output. Okay, if it's not, don't print it. Okay? So, is it hard? Again, you start by using the find and substring. You're going to make a copy of the pool words, and you compare it. Dennis and Menis, okay, with find. No, it's okay. Check it. If it's okay, print it. Then remove it. Start with the next word. Check it, the length. If the length is the same, call the function. If the mismatches are small or equal to the length of the word, print it. Go take the next one, and so on. This is it. Is the homework hard? It's not. I mean, there was a function, there was an example in your midterm, and you got the solutions for the midterm that was doing exactly the same.
That's exactly what I was looking at right now.
What?
That's what I was looking at. I was going to ask about that.
Yeah. The one that prints numbers 1, 7,
Yeah, 1, 3, 5,
1, 3, 5, 7, okay?
About the substring.
You can use that function basically. Substring, okay? So I think we have like 5 more minutes. Let's choose that example, particular example for your midterm, because you're going to need it for your homework probably. Which one was that, Ilhan? Which example? Which question?
The B option of 5B.
Okay, 5B. This is it. So how are you going to take words from the pool? Well, this is it. I'm going to erase this stuff, and I'm just going to play the role of compiler in order to see how it's working. This is how you're going to take words from the pool. Basically, you are going to finish your homework in 1 or 2 hours, not more. It's not that hard. But before doing your homework, it's very important, before writing any program, it's very important to divide some time to think about it. Okay? Because the programming part is the easy part, trust me. But coming up with the algorithm is the hard part. So we want to see the output of this guy here. Let's see what it's doing. We have a string called odd digits. You can assume this is your pool, okay? But it's not divided by commas, it's divided by empty spaces. Nothing else. So, we have here 1, comma, empty space. 1, 3, 5, 7, and 9. Okay, we have an integer which is called comma. And, okay, we're going to do it together. What is this guy going to return? From odd digits, we're going to find the comma. What's going to, what?
1.
No?
Oh, okay.
Okay, so odd digits, find, and we should find comma here. Which index is that?
3.
It's 3. 0, 1, 2, comma is at 3. So comma initially will be 3. Okay, sum is 0 initially. Now, comma, well, comma is not equal to M position. It's not equal to M position. We have a new string which is called digit. Let's write the digit here. Let's see what's the value of the digit. Odd digit substring from 0 to comma. What is substring doing? Starts from 0 and takes comma characters. Okay, So if I start from 0, from index 0, and I take comma was 3, 1, 2, 3.
Take 1 or 1 comma.
It, something.
The substring take 1 as a value or 1 comma?
It takes the first index is an integer. It tells the index where you should start. The second parameter is how many characters you take from that particular index. So we start from index 0, and we take comma characters from that index. We start from 0, and we take 1, 2, 3. Is this what you were asking?
Yeah.
Okay, so we take 3 characters. That's why digit is going to be 1. No empty spaces. Okay? Then we are printing the digit and some empty space here. Digit is 1. We are printing it. Empty space, and the cursor is here. Okay? Sum is equal digit plus length. What's the length of digit? It's 3. So sum is 3. Now odd digits is equal odd digits substring starting from comma plus 1, meaning comma is 3 plus 1, 4, starting from index 4, meaning 0, 1, 2, 3, 4 from index up to length. The length is maybe 15, 17, but even if I give 1 million, it's going to go up until here. So what do we do now? What do we have at the next week? We start from comma plus 1. 0, 1, 2, 3, 4. We start from this index, including the empty space. And this guy is going to be returned from odd digits and is going to be given to odd digits. Basically, this is what we have now. Okay? Now, we are finding the comma, find comma from odd digits, and we have what? But we have an empty space here. Okay? This is the problem. 0 from, so 0, 1, 2, 3, 4, 5, 6. Okay, so comma is going to be 6. Because we had an empty space, okay? And we go, string no position, yes, comma is not equal to string no position. We go here, again, substring from 0 up until comma. So we start from 0 and we take 6 characters. From here, 1, 2, 3, 4, 5, 6. Is that the case? Did I do a mistake here? Just a moment. So comma initially was 3. And I started 3 plus 1 from the 4th. From here, okay. Why do you think it's not the case?
Comma plus 1, and there's no space in that.
In the output?
No, in string odd digits, there's no space between. It's just a comma.
Are you sure about that?
Yeah.
Because if there's no space, it should have been something like this. Okay, it is like this. Okay. You're right. I thought there was a space. In that case, you know the solution. So this is space, this is no space. It looks like a space because this comma is much more closer to E than to T. Okay, so let's like this. Comma is from 0, 1, 2, 3, 4, 5. Comma is 5 now. Okay, we don't have any empty space here. Okay. Substring from 0 to comma. So we start from 0, and we should take how many characters? 5. 1, 2, 3, 4, 5. So basically digit becomes 3. Okay, this is given to digit. We are printing digit, we are printing 3, empty space. We increment the sum, we add the length. The length of 3 is 1, 2, 3, 4, 5, plus 3, it's 8. Okay. Then we start from comma plus 1 till the end. So comma plus 1 is 5, plus 1, 6. 0, 1, 2, 3, 4, 5. We start from 5 till the end. This part is erased, basically. We don't have it. Again, we should find comma now, and the comma is at 0, 1, 2, 3, 4, fourth position. Okay, is comma no position? No. We go here. The digit is 5 now. Okay, we print 5 here. The length is increased from 8 plus 4, it's 12 now. We start from comma plus 1 up until the end, meaning from 7. From here, this is our string, till the end. We find the comma, and it's 0, 1, 2, 3, 4, 5, fifth position. Okay, it's no position. Substring from 0 to comma, it's 7. Digits, it's 7. We print the digit with empty space here. I think the empty space should also be part of the solution. We should have this yellow background. We add the sum. It's 12 plus 5, it's 17. The substring goes from 9 till the end. Now when we try to find comma, we don't have any comma here. That's why we'll have no position. We are saying I mean, the problem is, I don't know, I mean, I'm just going to tell you, in my country, there's some oral exam. In the oral exam, if they understand you, see you that you understand what find is doing, what substring is doing, probably. But here you should write only the output. And I mean, you can just guess it. You can write something randomly.
It's very simple. It says plus 4 and the commas are there.
So if you add the commas, yeah, maybe 21, you'll get 21. You can go to objections, maybe. You can get a couple more points. Okay, any questions? Okay, this is it. If you have questions about the midterm, if you have questions about the midterm or homeworks, you can mail me. Remember, deadline is tomorrow. If there is anything you should solve, if you don't understand, you can come to extra recitations also. But I need only at least 5 of you. Okay, have a nice weekend. Thank you.